So we've talked a little bit here about outliers and what they are. So they're data values that are far away from the rest of the data, but we don't have a prescribed criterion for detecting them. So there's a couple ways we can detect outliers. One is using a box plot and the other is using z-scores. So remember, outliers are inconsistent or unusual measurements. They're far away from the rest of the data in a relative sense. How do we get them? Well, it could be just an error. Could be observed or recorded wrong. Data that's observed wrong or recorded wrong. That could be data that happens to be from a different population. So maybe you didn't consider your sample carefully. Or it could just be a chance event. So there's variation in data. Sometimes just a random variation in data gives you outliers. How do we detect them? So with box plots, we have to nail down 5 numbers here to form a box plot. One is the lower quartile, Q sub L, the 25th percentile. That's the median of the lower half of data. The upper quartile, Q sub U, that's 75th percentile, or the median of the upper half. And then we need to compute something called the interquartile range, so between quarters. We abbreviate that IQR, so that's QU minus QL. So that represents the middle 50% of the data, because it's 25th to 75th percentile. And then to construct that box plot, we are going to put the ends of the box at the lower quartile and upper quartile. Those are called the hinges. And then the whiskers, or line segments from our box plot, extend from the box to the farthest data that's inside the lower quartile minus 1.5 times the IQR to the upper quartile plus 1.5 times the IQR. So those cutoffs are what are called the inner fences. And then the outer fences, you take the lower quartile, subtract 3 IQRs, and the upper quartile add 3 IQRs. So we characterize potential outliers here are values that are between the inner and outer fences. We show them with an asterisk. And then confirmed outliers for us are past the outer fences. We usually show those with an open circle. At least that is our author's convention. So let's put these things to use here. Let's construct a box plot for the Croft improvement scores. Let's do it for the honey group. So that data I have already entered into my calculator. So here's that data entered in. So I went to stat and then edit to put that in there. So now I want to go to calc and I want to do one variable stats. So enter, come down to calculate and enter. So we see right there Q1 is 8. And if we scroll down here, median 11 and Q3 13. So 8, 11, and 13. So 8 here, 13 here, and 11 for our median. So that means that our IQR, our interquartile range, is going to be 13 minus 8, which is 5. And then our min and max score, those are also listed here. Max is 15 and min is 3. So 3 and 15. So now we do our inner fences. So lower quartile, so that's the 8 minus 1.5 times our IQR of 5, which leaves us at 0.5. And then we do 8 plus 1.5 times 5. So it's 8 plus 7.5, 15.5. So those are the inner fences. And then outer fences, so this will be 8 minus 3 times 5. So 8 minus 15, negative 7. Not going to have any negative scores. And then 8 plus 3 times 5. So 8 plus 15, 23. So our box here goes from 8 to 13, and the median's at 11. So if you look at this data, if you come down here, this is the box plot for the honey. data. So if you come down here, this left-hand side is at 8. This right-hand side right here is at 13. And then our median, whoops, that's 13. And then our median right here is 11. So if you come down there from the median, that is 11. And then this is, that's the box part. And then this is the upper whisker and the lower whisker. So you go up to the highest data value that is inside the inner fences. The inner fences go from 0.5 to 15.5. And if you look at this data here, if I go to Stat Edit, you can see the data in the list. I don't see the highest value here I see is 15. And if you scroll down, you don't see anything that's higher than 15. So all the data is within the inner fences. So this is going to go up to the high, which is at 15, right there. And then our low minimum was 3, so this is going down to 3, right there. So it's, and that's the lower whisker. So between the minimum and the lower half, the lower quartile, and then between the maximum and the upper quartile, as long as those values are inside the inner fences. So our inner fences here went from 0.5, about right there, up to 15.5, about right there. And then our outer fences went from -7 down here up to 23, which would be up there. So if we did have any data values that were in here, we'd mark them with a star, and those would be potential outliers. If we had anything that was out here or out here, we'd mark it with a circle, and that would be a definite outlier. So looks like no outliers in any of our box plots. But notice we can compare these nicely. The middle 50% for the honey group is higher than the middle 50% for the dextromethorphan, which is higher than the middle 50 for the control. We can also see that the middle 50% for the dextromethorphan is a lot more spread out than, say, control, and it's more spread out than the honey. We can also see on the honey group, we got a longer whisker on the lower side than we do on the higher side. That's telling us this is skewed a little bit to the left. Same thing, the left side of the box is bigger than the right side. Whereas the DM group, it's pretty even, and the control group pretty even. And then this is the overall box plot. So sometimes you do them vertical, sometimes you do them horizontal. I prefer horizontal, but I've seen them both ways.